Willem, this is our first Airflow 3D video.
I'm looking forward to seeing it.
So we've taken the McLaren, although it could be any Formula One car. A lot of these flows are all very similar. So what we're looking at is the flow around the front wing and how it works with the rest of the car. So if we could just sort of stop here, I think there's a misunderstanding, isn't there, that the front wing is all about creating downforce, and that's all that it does. And we've got a little representation of here of how much of it is actually pushing the front axle down, which shows you then how much it is doing other things.
It still needs to generate front downforce, but actually a huge part of its job is to manage the airflow, in particular trying to manage the front wheel wakes so that they don't disappear underneath the car and choke the floor, but also to just manage the flow in general to the rest of the car. That's its main job, really. It does still have to generate, and you can see it's a pretty decent sized device. It's still going to generate a lot of downforce, but its main role includes that airflow management.
Okay, so if we just sort of run the video on now, we can actually have a look at this front tyre turbulence, the wake that's coming off the front tyre, which is obviously the biggest problem for a Formula One designer. Again, you can now sort of see here. The front tyre, we can't put bodywork around it like a GT car. So
unfortunately,
what are
the rules prevent
here?
that. So the rules prevent you putting bodywork around the...
And you would if you could?
Oh, absolutely. We used to in the past. When the rules allowed us a window, we would put bodywork there to control it. And that was where, for example, barge boards started, that you had a window of opportunity and you used something to manage the flow. And normally the wake of the front wheel, if you didn't have good airflow management, is going to go straight into the rear wheel, basically. Just go straight back into the rear wheel if you had nothing there. And that's good for drag, potentially. You reduce the drag of the other wheel, but it's a disaster for the airflow going underneath the car. So actually what you want to do is you want to take those front wheel wakes and punch them outboard, far enough outboard, that they actually don't encroach, even in, say, yard conditions. You don't encroach onto the air that's going to end up going underneath the car.
Okay, so what we can see here is the airflow coming off of the tyres going in, as you say, to the rear wing.
Actually, that's very good, because it is extremely disturbed, that area. It's very turbulent and moving around and time dependent.
And it's doing no good for any aerodynamic devices at the back of the car.
Not for generating downforce, no.
So again, if we roll on now, we can now start to see that the effect that people are trying to create with the airflow that's now hitting the wing.
Hey, wow, that's good.
Again, if we can now stop here.
So Craig and I have been through this before it was all animated, and I've not seen the animation itself. That's very good.
So what are we seeing here? So now we've got these two blue spiralling airflows. So what's going on?
So next to the fixed central section of the wing, so the central section of the wing is a fixed section that is the same for all cars, and next to it you start to generate downforce. And all of the front wings, now this is a unique package, but all of them have a stack of flaps next to that fixed central section, and each element rolls up a small vortex, and they merge together to form a really big vortex, and it's the most famous vortex on a Formula One car. It's called the Y250 vortex.
And it's called Y250 because?
Because the central section of the wing that is fixed ends 250 mil from car centre line.
So it's because of the distance.
And we use an XYZ axis system, and Y is sideways.
And this is what we sometimes see in damp weather, of the air
you see the core. You see the core of that vortex. Now, if you were able to change in visualizing different amounts of air rotation, you would see a small core if you were looking at high-speed rotation, and as you came out away from the core of the vortex, you would see a bigger and bigger vortex. But if you start to do that on a Formula One car today, there would be so much vorticity you wouldn't be able to figure anything out, and nor would an aerodynamicist be able to figure it out anymore. You need to zoom in on the more important structures and then perhaps pan back and look in more general.
So we can see, obviously, this nice blue vortex, the Y250 vortex, coming out from behind the front wheel. And we can see that the wake from the tyre now is not going into the coke bottle area and into the rear wing and the diffuser.
Correct. So this vortex rolls up and is so powerful, it's tuned around the car by all the other devices, for example, the front brake ducts, the barge boards and turning vanes and things that are there. They're all designed to take that main vortex and manage it around the car, and it in turn then takes a big part of the front wheel wake and manages it outboard. And then the front wing end plate section, the outboard section of the wing, has a vortex that actually rolls up in the opposite direction, takes a different part of the wheel wake, and you can see from that pretty directly from, if you look in plan view at virtually all of the Formula One, they have a brutal kick at the end of the end plate to really kick that flow outboard, and the deflectors on the sides of the end plate they have co-rotating vortices that again merge into that second major vortex.